So in this section, we're going to talk about power series. Okay, so we're kind of coming into the capstone of Calculus 2. All right, so bringing everything that we've learned together. So let x be a variable. A power series in x is a series of the form n equals 0 to infinity of an, and then what we're going to do, we're going to add in x to the n. That's where our power, or raising powers of x to the n, right? So this is going to be when n equals 0, that's a to the a0, then x to the 0 is really just 1, so that's just a0, plus a1 x to the 1, plus a2 x to the 2. And what's happening here? My power is building up. Each term I go into the sequence and I add everything up, becomes the series. This is the nth term, x to the n, and then I just keep going forever and ever to infinity, right? So here's the idea, okay? Let me write. For each fixed x, we can test to see if the series converges. Okay? So for each fixed x, so say I pick some x value like x equal to 1 or whatever, if I pick like an x equal to 1, right? Then that becomes like a0 plus a1 plus a2 plus a3 and so on. And then I get my normal series that I'm used to looking at in a series from 0 to infinity of an, and I see does it converge, diverge, so on, right? So the thing that's important here, okay, these ANs, right? Those ANs are the constants. These are the coefficients of the series. Okay, they're the coefficients of the series. Those constants are the coefficients of the series there. Okay. So, more general. So if we do a more general approach, instead of being centered at 0 like we are here in this power series, I'm going to say a power series centered at C. So some number C. So this is kind of thought as a power series in x minus c, okay? Or you might see somebody say a power series about c, right? A power series about c. That might be another way you hear somebody say it. So what is a power series about c, or centered at c, or in x minus c? It's n equals 0 to infinity of an. Instead of x to the n, it's x minus c to the n, okay? And so what does this equal? It's a0 plus a1 x minus c to the n plus a2 x minus c to the n. I'm sorry. I'm not writing to the n here. That was my mistake. Okay, this is to the 1 power, to the 2 power, and so on and so on. And we just keep running through. N equals 0, n equals 0, n equal 1, n equal 2. Okay, so if if you think about like a parabola, like y equal x squared, right? This is a parabola whose vertex is at the origin 0, 0. If I had y equals x minus 2 squared, this would be that same parabola, except it's centered. That vertex is now looking like it's at 2 comma 0. So my c there would be 2. So it's the same idea when we're centering here. All right? So let me use a different color. All right. A power series may converge for some values of x and diverge for other values of x. Okay? So some values of x that I plug into my series will cause it to converge, while other values of x that I plug in will cause it to diverge. So really, we're just trying to see what values of x the series will converge for. Okay, that's what we're truly interested in. So the sum of the series is a function f of x. So we're about to turn a series into a function. The domain of the function is the set of all x for which the series converges. So the only elements of x that are in my domain are the ones for which the... Oh my goodness. Let's get out of that. The only values of x that are in my domain for this function f are the x values that cause the series to converge. Okay? So what series? It's f of x equal to the infinite series from 0 to infinity of a sub n x to the n, okay? Or more general, x minus c to the n, which is equal to a0 plus a1 x1 plus a2 x2 plus a3 x3 and so on forever, okay? So the values of x, so the domain all x such that the series n equal 0 to infinity of a sub n x to the n is convergent. Okay? So I'm just going to draw a little vertical bar here to represent my such that. That's the condition. All right. So here's my big theorem. For a given power series, so say you have some power series, n equals 0 to infinity, an x minus c to the n, there's exactly one of the following that's true. So either number 1 is true, either number 2 is true, or either number 3 is true. If 1 is true, then number 2 and number 3 can't be true. If 2 is true, then number 1 and number 3 cannot be true. And if 3 is true, then number 1 and number 2 cannot be true. So if 1 is true, then the other 2 are false. Exactly one of the following can be true. So the series converges only when x is equal to c. Okay? The series converges for all x. All right? There is a positive number r such that the series converges for absolute value of x minus c less than that positive number r, and diverges for absolute value x minus c greater than that number r. Okay? Greater than that number r. Now, in the scenario, and you may not understand this yet, but you will soon. In the scenario, you know what? We'll talk about that in just a second. We'll come back to this, okay? So, r is what? R is the radius of convergence. Okay? So the radius of convergence of a power series, that's what R is. R, when we're talking about a radius of convergence, we're talking about some interval on a real number line. The interval of convergence is the set of all x values for which the power series converges. So the interval of convergence is everywhere the series converges. Okay, so let me give you a number line here. All right, say we have some power series centered at C. C, okay, this is where it's centered. C for centered, right? Now, what are we told? We converge, okay, for some value where x minus c is less than r. Okay, x minus c is less than r. So what does x minus c less than r look like? So x minus c, absolute value less than r, is negative r less than x less than, or minus c less than r, okay? And then if I add c, add c, add c, these are all x's for which we converge between c plus r and c minus r, okay? So those are my ranges right there. So if c is in the center, I go out r in this direction. Okay, I add r in this direction, so this is c plus r. And then I go out r in this direction. This is c minus r. Okay, everything in this range here is in my interval of convergence. Okay, that's in the interval of convergence. Now, the interval of divergence is what? It's the absolute value of x minus c greater than r. So that's absolute value. So drop the absolute value. X minus c is greater than r, or x minus c is less than negative r. That's how I can split this up here using college algebra. Okay. So this is x is greater than c plus r, or x is less than c minus r. So x less than c minus r is over here. So that's everything on this side here diverges. Okay. And then over here, I want x to be greater than c plus r, so that's everything over here. Okay. Going this way diverges. So in the middle is my interval of convergence. In the center is C. The radius is that distance from the center to the edge of the interval, okay? So that distance is r. That's my radius of convergence. case of convergence right there. Okay. So let's talk about the other scenarios. I told you we would come back and I would make a little bit more sense. If the series only converges when x equals c, if x equals c is the only place where the series converges, then you're talking about a single dot right here, okay? This would be a single dot right there at c when x equals c would be an r equal to 0. Some radius equal to 0. The interval of convergence is a single point, okay? The case where this would be true would be, say we're dealing with some power series, okay? So some power series we're dealing with, right here, and the ANs by themselves would diverge. But if I make x equal to c, what does that become? C minus c to the n, that becomes 0. So now all of a sudden I took something that's diverging and I multiply each term by 0. The thing's 0 plus 0 plus 0 infinity amount of times is equal to 0. And that's the only way. It's pretty much a trivial case, but it's the only way that you can get that series to converge. So if you multiply every term by 0. And the other side of the coin says for all x. Well, what does that mean? Instead of just being at a single point at the center where the power series is centered at, we're talking about every x works. No matter what x I think of, it's going to work. So if c is in the center, how far does my radius goes out? It goes out. The radius goes out forever. Okay? So r here is equal to infinity. All right? The interval of convergence, how I like to abbreviate it, is what? It's negative infinity to infinity. All right? It's all real numbers. Basically, what this is saying is, I don't care what I plug in for x. These ANs are getting so small so quickly that it doesn't matter what I plug into this part here of my function. The series itself is going to converge. Okay, so pretty powerful. So my function has a domain for all x. Okay, for that given power series. All right, so here's what we're going to do. Okay, so we've kind of played around with every scenario. Let me keep backing up here. Except for this point here and this point here. So what happens at the actual endpoints? So when using the ratio test, we're going to utilize the ratio test here. You must check endpoints individually for convergence. So we'd have to check, does x equal c minus r work? Does the series converge when that's true? Does x equal c plus r work? When we plug that into our series, will we get a convergent series? Okay, so you got to check the endpoints. That's key there. So this little theorem is going to help us figure out the intervals, but then to get those endpoints, you have to just plug in those values, whatever the values might be, the c plus r, the c minus r, and see, does it work here? So we're going to run through an example here, and then we'll end the video, okay? So for what values of x does the series n equal 1 to infinity of x minus 3 to the n over n converge? Now, first off, is this even in the form where I can use a power series, right? So can I even use the power series here? So n equals 0 to infinity an x minus c to the n, right? Now, this looks like, okay, it starts at 1, right? So that's kind of throwing me off. But look, this part right here matches this part right here. My c here is 3. Okay, so we're centered at 3. Now, what is the an? The an is my 1 over n, right? So it's my 1 over n. So that's the an going on there. Now, does it bug you that we're not starting at 0? If it does, all you have to do to change this to make it work is to plug in an n plus 1 now and an x minus 3 to the n plus 1. That's kind of annoying. So really, these two things are the same. So let's just stick with the original problem here. You don't have to do this, okay? So let's run with it. So let an equal, okay? Let's let an be x minus 3 to the n over n. And let's run the ratio test. Ratio test. Okay, so let's use the ratio test here. So the limit as n goes to infinity of an plus 1 over an, this is equal to the limit as n goes to infinity. Everywhere I see an n, I'll put an n plus 1. So that's x minus 3 to the n plus 1 divided by parentheses n plus 1. Okay, all divided by x minus 3 to the n over n. Okay, now what I'm going to do is I'm going to keep this the same, change division to multiplication, and then flip the denominator. So this becomes keep, change, flip, helps me simplify. I have x minus 3 to the n plus 1 divided by n plus 1 times n over x minus 3 to the n. Okay? This is going to be very useful to us. Why? Because this piece right here factors. It factors to something pretty nice. It factors to x minus 3 to the n times x minus 3 to the 1, right? Why is this useful? Because these x minus 3 to the n's cancel. And what am I left with? I'm left with the limit as n goes to infinity, absolute value, n over n plus 1, okay, times x minus 3 to the 1, okay? Now, what do I know here? What do I know? Well, my limit is as n goes to infinity. So all I care about here is the n going to infinity. What do I know? This x minus 3 has nothing to do with n, so I can treat it like a constant and pull it out front. So the absolute value of x minus 3 comes out front, and then I still have my limit as n goes to infinity of n over n plus 1. Now, as limit as n goes to infinity at n over n plus 1, the degrees are the same, so I divide the coefficients. This is equal to 1, so I have multiplied by 1 here. All right, that limit is 1. You can use L'Hopital one time and you got it. Or factor out the n, whatever you want to do. I don't care. Okay. Now, what's going on here? By the ratio test, okay, the series converges absolutely for what? For this answer, x minus 3 in absolute value to be less than 1. If it's less than 1, it converges absolutely. So what does that tell me? That tells me that we have x minus 3 between negative 1 and 1. So x is between 4 and 2. Okay? So my interval of convergence. All right? So I need to work on this because right now I've got x in here, and over here I have 2 and I have 4. Okay? I need to do what? I need to check the endpoints. Okay, I need to check the endpoints. All right, so I need to check x equal to 2 and x equal to 4. So check x equal to 2 and check x equal to 4. What's in the middle? That's my center. I think my center of that interval is at 3, right? So before I do any math, I already know what the radius of convergence is. One of the things I was supposed to do is find r. R, the radius of convergence, is what? R is, well, what's the distance between 3 and 4? That's 1. The radius of convergence is 1. Whether or not it's valid at the endpoint doesn't change my radius of convergence. My radius of convergence is still r equal to 1. Okay? So, let's test at the endpoints. How do we test at the endpoints? All right? Check x equal to 2. Check x equal to 2. If I plug 2 into my series n equal 1 to infinity of x minus 3 to the n over n, this becomes n equal 1 to infinity of what? 2 minus 3 to the n over n, right? So what does this equal? This is the series n equal 1 to infinity, negative 1 to the n over n. Oh my goodness. What do you notice here? This is the alternating harmonic series. Okay, what do we know? We already know the alternating harmonic series converges. Okay? By what? By alternating series test. Right? Hadn't we done this a couple of times already? So we know that this thing converges. Okay? Now it converges conditionally, but if it converges conditionally, it converges, right? So I know that I can check off this side of the endpoint. So instead of a parentheses, this turns into a bracket. Okay? And now what about x equal to 4? Check x equal to 4. Okay? When I plug a 4 in, so I have n equal 1 to infinity, x minus 3 to the n over n. This is the series n equal 1 to infinity. And then I plug in 4 minus 3 to the n over n. This is equal to series n from 1 to infinity, 1 to the n over n, which is the series from 1 to infinity of 1 over n. Okay? What do I know about this? This is the harmonic series, and it diverges. How do I know it diverges? This is a p series with p equal to 1, okay? Which is less than or equal to 1, all right? That's my test. The p-series test tells me that this diverges. P equal to 1 here for the harmonic series, all right? So it's a no-go here, but it worked here. So what does that mean? This is a parentheses there, but a bracket on this side. So the question is, what's the interval of convergence? So the interval of convergence, you can abbreviate IOC, not AOC, right? IOC. The interval of convergence is the interval from 2 close inclusive to 4 open parentheses, okay? And the radius of convergence the radius of convergence is r equals 1. Okay, the radius of convergence is 1. So that summarizes up what happened there. Okay? So here's how we work these types of problems, all right? I write down my AN, I run the ratio test, I figure out what the answer is, I use the ratio test. The ratio test tells me if this answer is less than 1, then it converges absolutely, right? So when I run this test, okay, when I run that test there and I get something and I set it to be less than 1, then by golly, that's going to give me some interval that I can then check, okay? But say I run the ratio test. Say I run that ratio test and instead of getting, some absolute value like this, say I got like 0. Well, my goodness, no matter what x value I plug in to go with 0, is x times some 0 always going to be less than 1? Yes. So this is the scenario. If you get 0 here, then all x works. Okay? Meaning r is infinity and the interval of convergence is negative infinity to positive infinity. Does that make sense? However, if you run this ratio test and instead of getting, your absolute value or 0, instead you get, maybe you get infinity. Okay, so I'm running out of room here, so let me erase this. So maybe you get like infinity as your answer. Okay, when is infinity going to be less than 1? Well, the only time I can make infinity less than 1 is whenever I make my x equal to c, which makes it 0 times infinity. And then whatever that number is times 0 gets me 0, and that is the only way that I can be less than 1. And so then all of a sudden, the radius of convergence is 0, and the interval of convergence is the single point at C. Okay? So that kind of gives you all 3 scenarios of what might possibly could happen. A lot of times, this example, it ends up being the scenario that I showed you here through our example. But these are the oddball cases, and they do happen. Okay, so I just wanted to show you what would happen in all 3 cases. Okay? All right, guys, hope this video helps out.